Okay, welcome to Module 10.2. This is beyond development. We're talking about change, release, and quality assurance. And I thought it important to focus a little bit on this because it's one of the most neglected areas in IT systems development, mostly because it's a maturity thing. Quality assurance, change and release, when they're done properly, they serve a really good purpose for the company. But generally, people don't want to, or management doesn't want to put a lot of resources into it. And it's a little bit frustrating, especially if you've been in quality assurance. So in change management, technologists focus on the technology. They don't generally focus on the actual business value. It's, hey, we designed this Java module. It's great. We love Java. Java's great. Without any regard for the business itself. Many technically sound systems have turned into failures because the people side wasn't handled correctly. So for example, we say, well, we want to implement this patch or we want to implement this functionality. And it turns out to be a problem for the business. And that's happened time and time again. The system is only a success if it meets the user requirements and they're happy with it and using it. If we implement changes that cause a little hardship for the users, it's not a success. Whether it's a brand new system or whether it's updated to a system, that's a problem. Information technology is about managing change because everything changes. Our operating system changes, our database releases changes, we have new versions, both minor versions and major versions, and we need to manage all these things. This is a very challenging thing to do, and we need to have more focus, especially in IT, for doing that. The technical aspects are one part of it. Managing these changes to the environment is really the other. So change management, there's a little typo on there, is assist people in changing their work environment, in managing the change of their work environment. Because when you add this functionality, you may have to take a system down for a period of time, and that may cause a little bit of a problem. It shouldn't really be that bad. I mean, you should have it up and running before the next business day or within business hours. It should be running, so that shouldn't be a huge issue. But when we implement a whole new system that changes workflow, you might get some resistance. People might, deny the change. They might distort information they hear about the change and convince themselves that the new system will not change the status quo, that there's really no benefit to it. These are functions of change management, not in specific smaller upgrades or releases, but definitely in terms of larger implementations. People will say, I heard this new system doesn't work at this other company. It's horrible, and we're going to have to work triple time. And they'll do everything they can to kind of sabotage it so that the change doesn't go. Or people say, well, I'm not signing off on it. I don't care how bad you need it. And there may be a valid security reason to actually do that. You'll see those occur as well. In risk management, and a lot of people need to be involved in risk management, both from the project manager to the business analyst to the architects, all the way to your C-level or VP levels in IT and the CIO, CTO. Not all IT projects succeed. Now, I know that's hard to believe, but over 60% of them fail, and some numbers are as high as 70%. Why? Because they don't overcome the risks associated with the technology, that the technology may not be as mature, the software may not be as mature, or we don't have the skill set to adequately implement it, or it just doesn't meet the business requirements. Someone jumped the gun when they bought the software. One of the interesting things is a key predictor of whether or not an IT project will be successful is whether or not you have executive buy-in. If you do not have executive buy-in, there is a significantly higher probability that the project will ultimately be deemed a failure. So that's why it's very important to actually have senior buy-in. Now, that's a political thing that has nothing necessarily to do with technical risks, but it does have to do with the business risk. Because if your senior level people do not want the project, do not want the system, and a CIO is trying to push the system, you're going to have resistance to it. That resistance may lead to faulty requirements, may lead to lack of participation, lack of collaboration, and then have a failure. For those of you who are following what's going on with healthcare systems, especially hospitals, look at the implementations that are done by CIOs who are technologists versus those who are more clinically oriented like nurses. And I'll bet you'll find the difference because you'll see that the CIOs who are more clinically oriented had buy-in from doctors and senior level people at the hospital than the technologists did. The technical risks are usually on performance. Scope creep makes it too complex. It can't always be predicted, but it can be contained. And what that means is you would want to try and test some of the technical features in terms of non-functional requirements. Doesn't always happen, but you'd like to try and do that as much as possible. The business risks are that the business doesn't change, doesn't adapt to the new systems, and ultimately that is even a harder problem. Technical risk can kind of be overcome a little bit more than the business risk. So in risk management, we need to assess the risk, mitigate the risk, and adjust the overall approach. But like I said, the number one reason for failed projects is lack of executive support. So here's a risk management decision tree. Your book goes through a little bit of detail on this. I'm going to kind of just leave this for you to explore a little bit further. Now, in quality assurance is more than testing. It is really about developing the overall test plan, what are the requirements associated with it, creating the test strategy, and the overall approach to testing. It encompasses a lot more than just, here's a piece of product, go ahead and test it. You want the tests to be repeatable. You want to create a number of scripts and even automate them to some degree. So we say, well, we're going to have our own project plan. We're going to do our own requirements. We're going to have, what are the acceptance criteria for the test? Do we have each business requirement? Does it have a corresponding test case or test cases that are going to be tested against? We use this as part of our whole defect approach to understand what do we do when we encounter a defect. What are our test strategies? We will actually use some test data. We will report these test results. We'll create this defect log, and we go through this cycled approach until we get to a point where the business is satisfied that the testing may not be 100%, but it's acceptable to move forward. When we deal with defects, what do we do with a defect? A defect is a variance from a desired attribute. When we say we have a business requirement, such as that we have to be able to enter in a zip code, which is 5 digits, which means one of the test cases is ensure that it doesn't have 6 digits. So if it does allow it, that would be considered a defect. One of the things that we do is we have a defect process cycle, which says we identify what our defects are, we prioritize what those defects are, we then create a defect remediation plan by sending it back to the developers, saying we need you to do them in these orders, and then once we retest them, we can close that defect and say, yes, it now is meeting the expected levels or the expected functionality. So this is another example of this where I've split these up, and you have the defect management repository, and we'll do some status reporting and metrics on them. The idea is that you record the defects, and you see how you're doing at various levels, and we should see the chart go down, 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 down. First iteration, you should have the most number of defects. Second iteration, you have much fewer, and it should be somewhat more than linear. You should have an exponential curve downward. We would like to see that occur. If it doesn't occur, then you may have some other problems. If you see it goes higher from the first level to the second level, that could be a significant problem with respect to the developers or even the test cases, but something needs to be looked at. This would be an example of a reporting strategy. We want number of test cases passed versus failed, defects, number of defects identified by severity, defects caused by the root cause, defects by priority, aging, and trends. We want to put all these together in a reporting strategy because it's important for QA to communicate effectively, both for the developers and for the business, to understand what is actually happening during our implementation phase.